Five, four, three, two, one, go. We are live. Boom. Okay. Good afternoon, everyone. Greetings from VIDYAVARDHAKA College of Engineering. I am Chetan, working as an assistant professor in Department of Civil Engineering, and I will be the master of ceremony for today's webinar on energy efficient buildings by Mr. Gagan Devaya, a manager, Southern Zone, GRIHA Council, Bengaluru. Okay. First, I will be requesting our professor and head of the Department of Civil Engineering, Dr. S.K. Prasad sir, to introduce, to welcome all the participants to the webinar. Over to you, sir.
Yeah, thank you, Professor Chetan. Very good afternoon, everybody. We have had a small break in webinars. We used to have a series of webinars in the months of July and August. We had a little break, and now we have started with the new one today. And as was mentioned by Professor Chetan, we have the webinar on energy efficient buildings. All of us know how important is this topic, especially considering the energy consumption in urban areas, especially considering the sustainability point of view. And Mr. Gagan Devaya Kechira from GRIHA will be talking about energy efficient buildings today. So first of all, it's my pleasure to welcome Mr. Gagan Devaya, who will be the speaker for today's webinar. So welcome Gagan Devaya. And then, I need to welcome all the faculty members as well as staff members of the Department of Civil Engineering and other departments at VIDYAVARDHAKA College of Engineering. And they have been the backbone of all these activities which our institution is organizing. My welcome to each one of you. And most important is the participants. We had, in the last minute, we decided that we will make it open to, outside VVCE also, so that many people can get benefited. And we have had a good number of supporting participants in the past also, participants among academicians, among students, among working professionals, researchers. And today also I expect a large number of gathering for this. And it's just my privilege to talk about my institution a little. So VIDYAVARDHAKA College of Engineering is one of the most popular colleges in the state of Karnataka. It is situated in the heart of city of Mysuru. And I'm very proud and happy to mention that we are an autonomous institution affiliated to Visvesvaraya Technological University. We are NAAC accredited with A grade, and all our eligible departments, undergraduate departments, have been accredited by NBA. And that's why, we mean quality here. And I'm very proud and happy to talk about my department, which is a young department having, average age of faculty members in the range of about 34 years. And we have, faculty student ratio, very healthy, 1:14. Our department has been considered as a, recognized research center in by VTU. We have all the facilities for academics, research, consultancy, and I welcome each one of you to our department whenever you are free. So with this, I hand over back to Professor Chetan to go ahead with the, program. And I'm very sure the program will be very successful. I wish this a grand success. Over to Chetan, please.
Thank you, sir. And also, I welcome you to the webinar, sir. Next, will we move on? Now I request Professor Abhilash to introduce our today's speaker to the audience. Over to Abhilash, sir.
Thank you, Chetan, sir. Good afternoon, one and all. Myself, Abhilash BL. Today, I am glad to introduce our today's resource person, Mr. Gagan Devaya Kechira. Manager, Southern Zone, GRIHA Council, Bengaluru. Mr. GAGAN KECHIRA is an engineer with a master's in electrical engineering and renewable energy systems from University of Leeds, United Kingdom. GAGAN has over 8 years of experience in the field of renewable energy and green buildings. He has been working at GRIHA Council for almost 3 years. Currently, he is a manager and looks after business and development trainings and rating reviews for Southern Zone. Prior to joining for GRIHA Council, he has worked as an expert consultant on behalf of European Union in the photovoltaic rooftop cell set up at Ministry of New and Renewable Energy, Government of India. His role involved analyzing and providing solutions to specific issues related to the implementation of solar rooftop program in the country. He has represented the ministry at various state-level workshops and conferences. As a project engineer, buildings program at Bureau of Energy Efficiency, Ministry of Power, Government of India. He provided assistance in promotion and implementation of energy efficiency programs in buildings, including Energy Conservation Building Code, that is ECBC, and the program of energy efficiency in existing buildings. I welcome you for the webinar, sir.
Thank you, Abhilash sir. Before I am going to handle the session to our today's speaker, Mr. Gagan sir, I request the participants to listen carefully that, after the end of the speaker talk, we are going to send the feedback link in a YouTube chat box. So to whom are all going to fill the feedback link, they are going to receive the certificate at the end of the webinar. Okay. Now I request our speaker, Mr. Gagan sir, to take over the sessions. And also, if the participants have any questions, please post it on a chat box. We are going to ask to the speaker at the end of the session. Over to you, sir, Gagan sir.
Thank you so much, everyone. Am I audible? Yes?
Yes, sir. You are audible, sir.
Great. All right. So I'm just going to turn off my my video so that we don't have any interruption in the bandwidth, etc. And I'm going to share my screen right away. Please let me know if you're able to look at my screen.
Yes, sir. It's visible, sir.
Great. Okay. So good afternoon, everyone. At the outset, I would like to thank S.K. Prasad sir of VIDYAVARDHAKA College of Engineering, Mysuru, for giving me and GRIHA Council this opportunity to speak to all the participants about green buildings or sustainable buildings, and or which more or less correlates to energy efficient buildings as well. All right. So I think so. What we have done, or how we've structured today's, or what you can expect from today's, presentation, is we're going to talk a little bit about what is sustainability in a general context, sustainability in buildings. I'm going to introduce GRIHA Council to you, and then we're going to take up 3 different sections of GRIHA, where we're going to talk about energy, we're going to talk about construction management, and then we're going to talk about sustainable building material. And I will finish the presentation with a case study so that you can understand what we are trying to get at through this particular presentation. These are really pressing times. I mean, normally when we conduct these trainings and awareness workshops, we tend to do a physical one. But considering the situation that we are in, I think this is the best that we can do. So before I start off presenting my slides, I would like to apologize in advance in case there are any issues with respect to technical, difficulties here at our end. But we will ensure that there is no such things which come up during the course of the presentation. And I request the MC to let me know in case there is a phase where I become a little inaudible, because we've been experiencing some sort of network issues all over the country.
Sure, sir. Definitely, I will.
So let me start with what is sustainability, right? The moment you Google the word sustainability or you look for the word sustainability on the internet, it tells you that sustainability is something which focuses on meeting the needs of the present, to cater to our requirements at the present without compromising what is left for the future generation to meet their respective needs. I mean, most of you are based out in Mysuru. I'm sure most of you have been to Bangalore. Me, having born and brought up in Bangalore, I can tell you that climate change is real. the issues with climate change. Of course, right now we are in the midst of a pandemic. There are so many lives which are being lost, but climate change is something which cannot be ignored. And, it is something which is there, and it will stay in case we do not take necessary measures in order to mitigate the effects of climate change. So another thing is, when you Google the word sustainability, there are, you get to know that the three pillars of sustainability. Right now, you might think, why is he talking about the three pillars? You will understand the context when I get into the rating, when I get into the concept of sustainable construction or sustainable buildings. So three pillars in sustainability is social, environmental, and economic. It is not that sustainability is something that has come up very recently. It's something which has been one of the major issues from many years. And back in 2015, the United Nations member states adopted something called the SDGs, or it's also known as the global goals. SDG stands for Sustainable Development Goals, which are nothing but a collection of 17 global goals designed to be a blueprint to achieve a better and a more sustainable future for all. Now, with respect to, so what are these goals? So these goals talk about no poverty, it talks about zero hunger, it talks about good health and well-being, it talks about quality education, but at the other side, it also talks about affordable and clean energy, it talks about climate action, it talks about responsible consumption and production, clean water and sanitation. Now, if you look at the overarching need of the Sustainable Development Goals, or the reason why the Sustainable Development Goals were put into place, is in order to end poverty, to protect the planet, and also to ensure that all people in the world enjoy peace and prosperity by the year 2030. So it is not something which is, which we're trying to achieve by, let's say, 2050 or 2100. It is a short-term goal, but it's something which every UN member states are working together. Now, the intent of having this slide here is to tell the participants, or to convey to the participants, the importance of sustainability in today's day and age, and how the world, or the UN, has come together, the member states have come together to work towards achieving the Sustainable Development Goals. And there we enter into a new realm where we talk about sustainability in buildings. So when we use the word sustainability, there are many misconceptions. So some people might think, okay, sustainability in buildings essentially means that, I should probably save water. Some people say, okay, saving energy or being energy efficient is what sustainability in buildings means. Some may say, saving the environment, what is around me, or constructing a building which might not, harm the environment is what sustainability. Or you might say it is a building which would probably generate less waste even during the course of the construction or even post-construction. But the misconception is that it is not one factor. It is all these factors put together that constitute a green building or a sustainable building. So we should not be of the opinion that only by saving water will my building be sustainable, or only by saving electricity will my building be, energy efficient and sustainable, or by generating less waste it is going to be sustainable, or by saying that, okay, in case I preserve my surroundings I'm going to be sustainable. No, you will have to do all these things in order to achieve true sustainability in your particular project or your building. And then comes the question, what is the need for sustainability in buildings? Why do we need sustainability in buildings? So I've tried to establish the fact on why the UN member countries have got together with respect to developing the SDGs, working towards implementation or establishment of the SDGs, etc. But when you're talking about the building sector, why do we need sustainability? The first is the resources. I'm sure most of you know, or for those people who don't know, large amount of land, water, and energy and raw materials are used for the conventional buildings. So there's a lot of, if you're not sustainable, you're going to be using a lot of land, you're going to be using a lot of water. And in fact, 50% of the energy consumption globally is attributed to the building sector. So that means that if you are not sustainable, you are going to be wasting your resources. That is the first requirement of why we require sustainability in building. The next one is GHG emission. Now, GHG stands for Global Greenhouse Gas Emissions. And to tell you, the building sector is responsible for about 40% of the global GHG emission. So if you continue our unsustainable ways of construction, unsustainable ways of operating and running a building, then your GHG emissions is going to increase, and GHG emissions can be directly attributed to climate change. And the third aspect is the construction and demolition waste. Now, in case you're not, and this is something I think most of you civil engineers will be able to identify yourselves with, or sort of align yourselves with, because when you're talking about C&D stands for construction and demolition waste. So, in case you're not sustainable, there'll be a lot of construction and demolition waste that will be generated during a project. But how is that affecting sustainability? Because if you generate more and more C&D waste, that is going to end up in landfills if it is not treated. And having landfills is not sustainable. It is not green. It is not something which is good for the environment either. Therefore, the fourth and the third need for sustainability in building is, in case we're not sustainable, that will lead to a large amount of construction and demolition waste. And the fourth important factor of why we require sustainability in buildings is the impact our conventional construction has with respect to the flora and the fauna of that is surrounding our particular project site or the buildings that we're going to construct. So again, how does it affect? Now we're going to cut down more trees, more carbon emissions, right? Of course, everybody studied the process of photosynthesis when we were in school. So of course, the trees would require carbon dioxide to generate its food, and then it's going to release oxygen. So if you are going to be impacting the flora and the fauna, the living organisms, it is not going to be sustainable. Therefore, to sort of reiterate, the four aspects which drives or which should drive people to moving into sustainability in buildings is the use of resources, the GHG emissions that the building sector causes in the world, construction and demolition waste generation, and the impact unconventional or unsustainable buildings have on flora and fauna. So what is a green building? So green building is something that uses less water, it optimizes energy efficiency, it conserves natural resources, generates less waste, and provides a healthier space for the occupants as compared to a conventional building. So the image that you might see now on your screens is a GRIHA rated project. It is a beautiful project which is in Electronic City in Bangalore. It is a Titan new campus project. It is a 5-star rated GRIHA project. You can go to their site and find out more about it. But this particular building, the reason why I have put up this picture here is this building is performed extremely well with respect to both during construction and post construction as well. So yes, so green building is not something which just uses less water or optimizes energy efficiency, but it is something which does all these things, whether it is using less water, whether it is generating electricity or energy using renewable sources, whether it's conserving natural resources, whether it's being energy efficient, whether it's generating less waste, and also providing a very healthy space or an environment for the building occupants compared to a conventional building. And that is what defines a green building. So what are the key attributes? The key attributes of a green building is that the concept of sustainability is taken care during the course of the project. What do I mean by during the course of the project? I mean that it is integrated at every different step of the project. And this is something which I want you people as civil engineers, in case I'm assuming there are a lot of civil engineers who would be attending this program. I want you to understand that sustainability is not about, it's not in the scope of the architect, neither is it in the scope of an electrical or a mechanical engineer, or neither is it just in the scope of a civil engineer. It is in the scope of every individual who is working on that particular project, whether it is the architect, whether it's the construction agency where you civil engineers would come into place, whether it is the design team which is going to be designing your electrical systems or your renewable systems, it is the plumbing team, it is also your landscape team, and it also drops down to those people who are providing you with the materials such as your flooring, your paneling, your and your false ceiling, etc. So the key attribute of a green building, or the first key attribute of a green building, is the concept of sustainability is embedded at each and every step of that particular project, right from the design to the operation and maintenance and everything that falls in between. The second thing is use of sustainable building materials. Now, I'll touch upon why do we use sustainable building materials and what is the need to use a sustainable building material. But right now, let's just stop it at that point and say that the use of a sustainable building material is another attribute of a green building. The third is use of technologies, which are efficient, technologies which are far more sustainable than the way that we're the business as usual model that we use. And the fourth thing is that it is able to reduce your resource utilization, whether it is during construction or whether it is post construction. All right, so the four key attributes, let me just reiterate it. One is the concept of sustainability being embedded at all stages of the project, whether it is design, construction, operation, and maintenance. The second is the use of green building products or products which are sustainable. The third is use of sustainable construction practices or activities during construction. And the fourth thing is that it attributes to saving of resources during and post construction as well. So the components of a green building is the location and the design. So it also matters where your project is. So we will though I will not be covering it, I'll give you a small example. Normally, if it's a physical training program or a physical awareness program, I would have asked you a question as to if you were to finalize a plot, or if you were to go on and finalize where you want to purchase a flat, what are those things that you would look into? Most of the times we get the answer saying that, okay, how close is it to a bus stop? How close is it to a restaurant? How close is it to a school? Exactly. So the location of your particular project plays a huge impact on how sustainable the project is turning out to be. Why? Now, GRIHA says that if there are basic amenities, what do we mean by basic amenities? It could be your restaurants, it could be your shops, pharmacies, banks, etc. If that is available within 500 meters walking distance from your project, then you can get points for it. This is what GRIHA says. But why is that sustainable? Because we understand that in case certain amenities are available within a certain walking distance from your project's main entrance, you would walk rather than taking your vehicle. And how is that helping sustainability? If you're going to walk, you're not going to be burning more carbon. If you're taking your bike, your car, you're going to be burning more carbon, right? So that is not sustainable. So the location is the first thing that talks about, that's the first component of a green building. And then the design, the way that you design. So of course, when I come to the last part of our presentation, I'll be presenting one of a case study where I will tell you how just by the design, the project has been able to achieve certain magnificent things. The second component of a green building is the resources. As I said, resources are something which are used during construction and also post-construction. So things that is used during construction could be building materials, energy, water, and waste that is generated. And even after the building has been constructed, when it's being occupied, when it's being operated, you are definitely going to be using energy, water, and waste. You'll be generating waste rather. And the third component of a green building is that the green building is basically somewhere where you are going to be the people who will be residing or functioning out of these green buildings would be healthier and they'll be more comfortable. So what are the benefits? What are the, so we basically covered things such as what are the key attributes, what is the requirement of a green building, so what are the benefits? And I said at the first slide that I presented the three pillars. So let us look at the benefits of a green building in context to these three pillars. Environmentally, you're able to consume less energy or less water. So consuming less energy or less water obviously is environmental. Why? Because in a country like India, 60% of our energy generation is through thermal power plant. So what happens in a thermal power plant is they're going to burn coal and they're going to generate electricity. So burning of coal is not something which is good because it's more carbon emissions, etc. So therefore, if you are able to suppress or you are able to reduce your building's energy consumption, you are definitely impacting the environmental aspect of it. And similarly, with respect to water as well, in case you're going to be using less water during construction and post-construction, you are directly benefiting the environment. Second thing is economically. Why? If I am able to reduce less energy, that essentially means I'll be paying less bills. So environmentally, economically as well, the green buildings are is benefiting in today's day and age. And also another aspect is creation of jobs. So green building is an industry. Of course, I'm also going to touch up on the factors of of how the market looks at this current stage with respect to green buildings. So benefits with respect to jobs as well. And finally, the third pillar, social. So because of these green buildings, the cognitive scores of those people who have been working or who are residing in this particular green building increases drastically. And this is not something which GAGAN or GRIHA Council is saying, but this is something which a study says. So all three pillars of sustainability is something which is being benefited because of you constructing a green building. So by constructing a green building, or by residing in a green building, you are able to take care of the environmental aspect. You're economically better because you're going to be spending less amount of money. You're able to create more jobs. And the people, if you're residing in a green building or a sustainable building, you are basically going to be, your productivity is going to increase. You're going to be much healthier and a comfortable environment as well. So before I get on to GRIHA, etc., let's talk about the climate of the world. Now, as per the World of Copenhagen Climate Classification, there are about 29 different classifications of climate. Now, you might be thinking that, okay, this is not a climatology class. Why is he talking about climate of the world during this presentation on green buildings? But please remember, this is very, very important with respect to today's context or today's ways that we are constructing buildings in. Now, I'm sure as civil engineers, you would have heard of the NBC or the National Building Code. Now, NBC has broken India into 5 climatic zones: hot and dry, which is normally the western, so that is Rajasthan, Gujarat, some parts of Maharashtra. Then we have the warm and humid, which is the coastal zones of India or the northeastern zones. Then we have the composite. This is the northern and the middle part of India, where we have extreme summers and extreme winters. Then well, I'm lucky to be sitting in a place which is which is a temperate climate, which comes under the temperate climatic zone. And then we have cold climatic zones, which is towards the northeast and the north part of India. Now again, if you go back to the previous slide, there are 29 classifications here, whereas in India, there are 5 classifications. Now, look at this particular slide. Again, if it was a physical awareness workshop that I was conducting, I would have asked you to identify which of these buildings are in India and which of this building is not in India. Now, ironically, building A, B, and C look very, very similar, but unfortunately, building A and B is in India and C is in the US. Now, in order to bring out the importance of why I presented this slide to you, let's do a bit of a comparison. Now, comparing India and the USA, of course, the US has a larger land area compared to India. With respect to population, of course, India is populated much more than the United States. Then, if you're comparing India and the United States with respect to metro population, city-wise, cumulatively, India's metro population is higher than that of the USA, and the metro land areas is higher in the USA when compared to India. However, the population density, because of the population and the area being, population being more and the area being less, in India is much more than it is in the USA. All right. Climate-wise as well. So let us take an example of, let's say Mumbai and New York City. If you look at the table, the highest temperature recorded, the maximum temperature that is recorded in Mumbai is in the month of April, which is 42.2. And the lowest that is recorded is probably in the month of January, which is 16.8. Now let us look at the maximum temperature that is registered in the city of New York. It is about 29 degrees Celsius, and if I'm not wrong, it is the month of July. All right. From 42.2 degrees to 26 degrees. So that is the temperature difference in these two cities. And that is when the question arises that, going back to my previous slide, when our climate is not the same as the US, when our land features are not the same as the US, when our population and the population density is not the same as the US, then why do we insist on constructing buildings that can be constructed in the US? Please remember, glass facade looks beautiful. There is no question about it. But what are you trying to do with it? You are going to incur more energy because your glass will be allowing the heat. It will also be allowing the sunlight to come in. So if you have more heat trapped in your building, it essentially requires that you have to install higher capacity of cooling systems, and by running these high capacity cooling systems, you are incurring more energy bills. So is that what we want? Absolutely not. So that is the reason I made a comparison between the India and the US with respect to the land, with respect to the population and the climate as well. And that is where GRIHA comes into the picture. So here is where the inception of GRIHA started. So this building that you see is based in Madhapura in Hyderabad, currently Telangana. So this was the first green rated building in our country. All right, and this is a LEED Platinum rated building, and this was rated in the year 2001. Now, LEED is another sort of rating system that is available in our country, and it is being run by GBC, the Green Building Certification Incorporated. All right, which was erstwhile also known as the USGBC, or the United States Green Building Council. Of course, that is the part of the training wing at this point of time. So USGBC came out with a rating, and this particular building was rated under the USGBC's LEED rating variant, and it got the highest rating, which is the LEED Platinum rating, back in 2001. Now, please remember, when you are rating a green building, the three entities who are involved. One is the client, which in this case was CII, Godrej. The second is the green building rating body, which in this case was USGBC, or the United States Green Building Council. And the third entity is called a green building consultant. Now, this project was, being consulted by TERI, or the Energy and Resource Institute, erstwhile known as Tata Energy and Resource Institute. Now, when they were collating the documents, when they were doing the simulations, etc., and they were comparing it, they realized one fact. They realized that the concept based on which this particular building was being rated is not as per the Indian context, be it the climate or be it the norms, like say the NBC or the CPCB norms or the ECBC, etc. So then TERI decided, why don't we have our own indigenous rating system? And that is how TERI GRIHA was launched in the year 2005. And that was how GRIHA that was the inception of GRIHA. Now, GRIHA stands for Green Rating for Integrated Habitat Assessment. That is the full form. It is nothing but a tool. When you're rating your particular building, this GRIHA becomes a tool to facilitate the design, construction, and operation of a green building, and in turn measure how green your particular building is, or rather measure the greenness of a building. Now, this particular rating body, GRIHA, which I represent, is being adopted by the Ministry of New and Renewable Energy, Government of India, and of course was developed by the Energy and Resources Institute. And the formula by which we go is what gets measured gets managed. I have a very small anecdote to this. Now, growing up, or even now, I'm sure for those people who have kids, or who have been in the position where your parents would compare your electricity bill and say, oh, in June I spent only 1,000 rupees on electricity bill. Why even in the month of July, having the same climatic conditions in Mysuru, why am I paying 200 rupees more? What is going wrong? Turn off the light before you exit a room. Turn off the geyser. Why are you having the geyser? So until unless you measure it, you will not be able to manage. Right? So that is the concept by which GRIHA Council works. What gets measured gets managed. The timeline, as I said, is TERI GRIHA was launched in 2005. It was adopted by the Ministry of New and Renewable Energy in the year 2007, and the council itself was established in 2009. Now we have three centers. One is our head office based out in New Delhi. Then we have a regional center here in Bangalore, from where I'm speaking to you, and we have another regional center in Mumbai as well. So over the last, let's say 15 years since the inception of TERI GRIHA, there are a lot of agencies, municipalities, and states that have adopted GRIHA. Some municipalities such as Pune, Pimpri Chinchwad, Noida, Greater Noida have adopted GRIHA. Some states such as Delhi, Punjab, Haryana, Goa, Sikkim have also adopted GRIHA. And organizations like the Central Public Work Department, the NBCC have also adopted GRIHA. Now, how they've adopted it, we'll come to that at the end. But right now, we have more than 1,700. In fact, now it's more than that. It's more than 1,900 projects that are registered, and almost about 525 million square feet of built-up area which are GRIHA registered. And over the years, we've got a lot of national and international endorsements. The first one was, of course, back in 2007, when the Ministry of New and Renewable Energy adopted GRIHA as the national rating system. The next is GRIHA was recognized as a tool for implementing renewable energy in the building sector by the Climate Minds, is what happened last. Everybody can remember a very sad incident which happened in 2015 in Paris. There was a terrorist attack in Paris. A few days later, there was a conference by the United Nations Climate Change Conference called COP, Confederation of Parties 21. It is also known as COP 21, where each country before this particular Paris or COP21 had to submit something called the INDC. Now, INDC stands for Intended Nationally Determined Contribution. It is nothing but a country like India saying, okay, I am going to be doing these interventions in my country, because of which I am going to be mitigating the negative effects of climate change. So in that thing, India said 8 things. You can Google INDCs of India, and you will see 8 different things. It's a beautiful document, about 30 to 40 pages. So there, the most important page is where they have written about what is India trying to do as a country in order to mitigate the effects of climate change. And there were 2 very significant things that were mentioned in that particular document that was submitted to the United Nations Climate Change Conference. That was that India is going to reduce its carbon emission intensity of its GDP by 30 to 33% by 2030 compared to the 2005 levels. All right. So that was the first thing that they said. And the second thing that they said is by 2030, 40% of our energy generation. Remember, I just told you a few slides ago that 60% of our energy generation is through thermal power plants. So India committed saying that by 2030, 40% of our generation will be through non-fossil based fuels or renewable energy. 2 very significant contributions with respect to energy efficiency, renewable energy, and sustainability as a whole. Of course, India has also committed a lot of things with respect to forestry, etc., etc. But these are 2 significant things. And in that document that was submitted to UNFCCC, GRIHA has been recognized as India's own green building rating system, and it said that it will be a part of the mitigating strategies for combating the climate change that is plaguing the world in today's day and age. So this is the last and probably one of the most significant endorsements that we've received. Now in India, when we talk about GRIHA rating variants, we look at ratings only from 2 standpoints. So what is that GRIHA does? GRIHA essentially is that rating body which is going to be rating a building based on the sustainable aspects of it. All right. But in GRIHA, we don't look at buildings from the typologies, meaning that we don't have a separate rating for, say, residential building. We don't have a separate rating for a office building or an institutional building. Rather, we look at buildings from 2 standpoints. One is whether it is an existing building, and the second one, whether it is a new construction. Under new construction, we have 4 variants. One is called the SWAGRIHA, simple, versatile, affordable GRIHA, using which we are able to rate any building which has a built-up area of 100 square meters to 2,500 square meters. So this would basically, constitute a smaller building, a standalone office, a bigger residential building, etc. Then we have the most prominent rating variant that we have, GRIHA, and which we will be discussing in the slides up front. So this is a rating variant which is applicable to any building which has a built-up area of 2,500 square meters. Doesn't matter what typology it is. And then we said, okay, now we have looked at building from a smaller construction to a bigger construction. Let us look at it from a larger development perspective. So what I mean by larger development is IITs, IIM campuses, these townships which are developing. Let's look at it from that context. And therefore, we developed something called GRIHA LD, or GRIHA for larger development, which is for any project which has a site area of 50 hectares or 125 acres and above. And recently in 2017, under the purview of the Pradhan Mantri Awas Yojana, or the Housing for All scheme, GRIHA launched something called GRIHA for affordable housing as well. With respect to existing building, we have 2 variants. One is called GRIHA for EB. Again, this is for any building which is existing, that is, which has been operational and has a built-up area of more than 2,500 square meters. And then we have something called GRIHA for day school. It's a very fun rating system which is only for schools. And there, I told you there are 3 entities who are required for rating a building: a client, a consultant, and the rating body. Here, the school becomes the client, and the consultants are the students and the teachers. So what we're trying to do here is, in the course of them documenting what are the sustainable aspects of that particular school, we are trying to teach the kids about sustainability. And who better to teach? If you plant the seed in those little brains, as we progress, as the day goes, as the years roll on, I'm sure they're going to be looking at a more sustainable way of a lifestyle. And of course, we also have another rating which was launched a couple of years ago called GRIHA for cities, where because of the 100 new smart cities which are coming around India, we have developed this from a perspective of a city. So there we are going to talk about the industries, the existing and new settlements, the governing bodies, how are they managing the waste, how are they distributing the electricity, etc., etc. So you'll get more details about it from our website. So like I said, we do not go on a typology of a building, rather we go on the size of the building. So we rate any type of the building, whether it is homes, offices, schools, hospitals, banks, institutes, museums, airports, etc., etc., etc. Fun fact, we've also rated a dhaba in Haryana. There's a dhaba called Bhajan Dhaba, which is Swagriha rated building. So it is no limitation to the typology. You can go and register the project and get it rated. Now let's talk business. Let's discuss about why we are a part of this conversation today, or this particular small webinar that we are conducting. So what I'll be doing is, I'll be talking about GRIHA version 2015. Like I said, it's the most prominent rating variant that we have. The key features of the GRIHA rating is, it's a performance-based rating system, meaning the better performance of a building, the higher the rating that they're going to get. So normally in GRIHA, the points that you'll be, like your papers, in case you're students, you're evaluated on 100 and 125 if you consider the internals as well. So in GRIHA, every project is rated on a scale of 1 to 100 in this particular variant. So the higher the points that you achieve, the better the rating that you have. So the second very fun thing, which you will understand when I go into the slide, is it's a common sense oriented rating system, meaning that we have non-applicability clause. So what do we mean by that? We mean that no two projects are the same, right? So you'll understand what we say, what is it that I'm intending to say in the slides which are going to come up next. But what you need to understand at this point of time is, GRIHA doesn't compare, even if it's the same typology. Let us say that you're constructing a building in Bangalore and same plan of a building in Mysuru, we will consider as two different projects, and we will say that the site features can be different. Now, the third thing is emphasis on integrated, design approach towards green buildings. Like I said, it is not just the architect who's responsible in making a building green, rather it is everybody. So everybody, whether it is you're the architect, whether you're the civil engineer, whether you're an electrical engineer, or whether you're the person who's laying the tiles for the project, have to be on the same page. And that is the beauty of sustainability. The next thing is, we lay emphasis on cost-effective strategies for making building green. So we do not say install a 5-star rated AC or install a 5-star rated fridge to make your building sustainable. No, we say do whatever it takes. You can even install a 3-star rated, AC in your room, as long as it is meeting the thermal comfort requirement of that particular room. So we are not saying that you have to make a building product. You have to use products to make your building green. No. Or rather, let me put it this way: we're not saying you have to use expensive products to make your building green. No, you can use whatever strategies that you want in order to make your building green. And the final key feature is, we rate both AC'd, non-AC'd, as well as hybrid buildings as well. Hybrid buildings essentially are buildings which are partly conditioned and partly unconditioned. And when I mean conditioned and unconditioned, it is AC'd or non-AC'd. GRIHA version 2015 has 9 different sections. And you need to identify what are the sections, and always think about the 3 pillars of sustainability. How is GRIHA tackling the, or addressing the requirements of the 3 pillars of sustainability? So here we have site planning, construction management, energy, occupant comfort and well-being, water, sustainable building materials, solid waste management, socio-economic strategy, performance monitoring and validation. So these are the 9 different sections based on which your particular building is being judged or being rated on. The point weightages are in front of you. So the highest weightage in our particular rating is given to energy, which is about 20% type. And if you look at the description that is given, in your YouTube streaming, it says that energy efficiency is an important aspect, and identifying the importance of not just energy efficiency but energy in general, and the role it plays in making a building sustainable is what we are trying to address here. And therefore the highest weightage in this particular rating variant or in any other rating variant of GRIHA is given to energy, which is about 20% type. Then we have water. Now water in our country, we all know, I mean, we have read articles in the newspapers, we have read reports, we've read studies saying that the country is running out of water, Bangalore is running out of water, but unfortunately we do not look at water as a commodity, right? So therefore we thought, okay, it's high time that water is looked up as a commodity. What the importance of water in a project post construction and during construction is taken care of, and therefore the second highest weightage is given to water, which is about 17% type. Then we have sustainable building materials, which I'm sure all you civil engineers would associate yourself with, which is about 14 percentile. Then we have about 12 percentile, which is given to occupant comfort and well-being. Then we have 9%, which is given to construction management. Then we have about 8 for site planning, 8 for performance monitoring and validation, and 6 percentile each for solid waste management post construction and socio-economic strategies. So in this, again, please identify those three pillars of sustainability and how GRIHA is trying to tackle it. Just to give you an example, by taking care of energy, I'm taking care of environmental as well as the economic. By taking care of water, I'm taking care of the economic as well as the environmental. By taking care of the comfort parameters, I'm taking care of the social. By addressing the socio-economic strategies, I'm taking care of the social. So that way, GRIHA is addressing each pillar of sustainability, whether it is social, environmental, or economical. So today, what we're going to do in the next 45 minutes to an hour is we are going to be talking about 3 sections: energy, and 2 other sections, that is sustainable building materials and construction management. Now energy, because I want to bring out the fact that energy is a very important aspect in today's day and age, and sustainable building materials to tell you that you as construction, as civil engineers, have a huge role to play in the sustainable building industry. Why? Because if you put together the points that are attributed to sustainable building materials and construction management, that is 14 percentile plus about 9, so that almost 23 percentile of our GRIHA rating itself is attributed to your sector or to your to the area that you are working in or you're studying about. So that needs that is where I need to bring out and tell you that what an important role you civil engineers would play in this particular green building industry, the sustainable industry. So the points that you can achieve, I said it's a performance-based rating system. So I said earlier on that you'll be rated on 100. In case your project is achieving somewhere between 25 and 40 points, you're eligible for 1 star. Every 15-point increment, you will get 1 additional star. So if you want to look at those buildings which are sustainable or highly sustainable, those would come under the bracket of a 5-star rated GRIHA projects, and that would have a point between 86 and above. Now, without any further ado, let's get into the best part of our presentation. So I said energy section of our rating has 3 criteria. Okay, so each criteria has appraisal. So appraisal meaning what is it that GRIHA is asking a project to do. We will take that up in the slides which come up next. But out of the 20 criteria, it's broken down like this. You may also notice points given across the criteria, and also something called M. M essentially means mandatory, meaning that if you don't comply with the mandatory requirements of these criteria, then your project will be denied the rating. Meaning that GRIHA is trying to ensure that there is a bare minimum efficiency or renewable energy generation or use of low ODP materials which is being done in your project. So 14 points in our energy section is on energy efficiency. The 7 points are attributed to renewable energy utilization, and no points are attributed to low ODP material because the entire criteria is mandatory. Moving on, the approach that GRIHA uses in order to make a building, let's say, sustainable energy wise, is something called demand side management and supply side management. Of course, we've heard this term, before, probably not in the context of what I am going to say. So how is it we are going to make a building demand side managed well? Is by these things. So first is by making the building efficient, by ensuring the building is energy efficient. How are we doing that? By probably providing outdoor lighting fixtures which meets the minimum luminous efficacy, or which is provided with automatic timer control. That is one way of reducing your energy consumption. The second thing is by designing itself. So like I said, the design of a building also plays a factor in making a building green. So fun fact, the way that you orient a building, in which direction the building is oriented, will have a huge impact on your energy consumption of that particular building. I'll give you a very small example. Let us say that a building is oriented in such a way that the common spaces, let's take a college, let's take the institute. Let us say that the commonly utilized space, that is your classrooms or your HOD's office, or let's say the principal's office, etc., is oriented on the east and the west facade. That is the east and west direction. Now, is that efficient? Definitely not. Why is it not efficient? Now, the sun rises in the east and sets in the west. So as it takes a path, what it is doing is it is constantly heating up your spaces, which is in the east and the west direction. So if it is constantly heating your space, what would you do to make yourself feel more comfortable? You will either turn on the fan, or in case you're sitting in the office, you will be turning on your AC at probably a lower set point. And how is that affecting your energy efficiency? Because of you turning on your fan, or you basically turning on your AC, you're consuming more energy. So that cannot be energy efficient. If that building cannot be construed as energy efficiency. So when you're talking about design optimization, we talk about the window to wall ratio, the skylight to roof ratio. How are you shading? See, daylighting is good. Daylighting coming into your building is good, into your space is good. But with the daylight, there is also two aspects. One is heat which comes into the building, because of which you will require more cooling, and also the glare. So you don't want the glare to come in, because again, it becomes if it's too much glare, it becomes uncomfortable for the people who are residing in that particular thing. And also, finally, we talk about efficient systems. So when we're talking about efficient systems in making a building, energy energy efficient, it basically talks about using ECBC, that is Energy Conservation Building Code. I will tell you about ECBC, and then talking about the EPI. So that is the Energy Performance Index. So I will also tell you what EPI stands for. So first step in order to make your building, or to optimize the energy of your building, is to make your building energy efficient, and that can be done by your design. That can be done by the system that you're going to be using. So that's what GRIHA is also trying to tell you. First, manage your demand. First, manage what you're going to be doing, your consumption of a building. Then once you reduce the demand, then we do the supply side management. And how are we going to be doing the supply side management? By meeting the requirement of your energy through renewable energy sources. So it could be solar, it could be wind, it could be biogas, it could be anything which is considered a renewable energy under the Ministry of New and Renewable Energy. So you see the beauty here. First, we are reducing the energy demand by making my building more energy efficient, and then we are offsetting the required energy. So if I can give you another example, so let us assume that my building is basically, if it is inefficient, let us say that it is going to be consuming about 1,000 units of electricity a month. By making it energy efficient, I can reduce that requirement to 600 units. And then in that 600 units, I can cater to those 600 units, or a part of the 600 units, by using a renewable energy system. And that is exactly what is GRIHA also trying to tell. So we spoke about ECBC. So ECBC is nothing but Energy Conservation Building Code. This is something which is developed by the Bureau of Energy Efficiency, which is a department under the Ministry of Power, Government of India, where I had the good luck of working for a few years. So there we worked on development of ECBC. Of course, this is the older version of ECBC. We have a newer version which was launched in 2017, but this particular rating variant talks about ECBC 2007. Now, ECBC looks at 5 components of a building. The building envelope. So what do we mean by the building envelope? It means the building's walls, the windows, the glass, etc. What comes as the facade, the envelope of a building, the roof, etc. The second aspect talks about HVAC, or heating, ventilation, and air conditioning. So how is it? Are you, what kind of chillers are you providing? What kind of AC systems are you providing? Are the efficiency of these chillers and AC systems as per the requirement? That is what ECBC does. Service hot water and pumping is another aspect which ECBC 2007 looks into. Then we talk about lighting, where lighting, artificial lighting is looked into. What is the is it as per the requirement, as per the task specific lighting requirement? And then finally we talk about electrical power, where we're talking about the motors that are installed in your site, the kind of transformers that are installed, the kind of piping and the ducting that you use, etc., etc., etc. Now please remember, when you, even at your homes, fine, I think I'm giving a long example. Let's say that's a commercial facility. When we're talking about a commercial facility, the highest energy consumption in your particular building will come into HVAC, that is your heating, ventilation, and air conditioning. And the second highest would come into lighting. Right. So these are the two things where it matters, and therefore ECBCs try to address all these things. And in GRIHA, only and only if you are able to meet the mandatory requirements of this ECBC will your project be eligible for the rating. And also GRIHA says that all your fans, that is your ceiling fans, have to be BE star rated. Now, apart from that, we also talk about the envelope peak heat gain. So I told you that, with the type of facade that you're going to design, there is some heat which is being transferred. So please understand that heat is not only transferred to your windows, but heat is also transferred to your roof, and it is also transferred to your walls. So GRIHA is saying, as per your climatic zone, you will have to meet the GRIHA's threshold for building envelope heat gain factor. So again, this heat gain factor, you might be wondering, why is he talking about heat, etc. Now, in case yours does not fall into the purview of what is being mentioned here, it basically means that you will have to design a heating and ventilation and air conditioning system that is of a higher capacity. And what happens if you install a higher capacity system and constantly using it, your energy consumption would go high. Therefore, this is something which is taken care of under the energy efficiency criteria of a GRIHA rating. Then we say that all 100% of your outdoor lightings, whether it is street lights, whether it's your floodlights, whether it's your facade lights, everything has to have a minimum luminous efficacy of 75 lumen per watt as per GRIHA. And then we come to the point of an EPI. And EPI stands for Energy Performance Index. It might sound complex, but it's very simple. It is nothing but your building's annual energy consumption divided by its built-up area. So that is what EPI is. So what GRIHA says is, depending on the typology of a building, depending on the scenario of your building, or the operational aspects of a building, your EPI has to be less than what has been prescribed by GRIHA. For example, let us say that I work in a commercial facility in Bangalore, which comes under the moderate climatic zone, and this facility is operational for 5 days a week and 8 hours a day. So there I have to prove to GRIHA Council that my building's energy performance index is less than 75 kilowatt hour per square meter per year. In case it is not, your building will be denied the rating. Now, in case it is, then you will be eligible for the rating, and also the higher the reduction that you exhibit, the higher the points that you get. So this is how GRIHA is taking care of the energy efficiency aspect of energy. Next, we talk about renewable energy utilization. Of course, the first thing that comes to our mind when we talk about renewable energy is solar. So because that's something which we see, whether it is hot water or whether it's solar PV panels. Of course, the other source of energy also, which is considered as renewable energy by the Ministry of New and Renewable Energy. So what GRIHA is trying to do, and of course, like before I come to what GRIHA is trying to do, see, India, I said, like 40% of our energy generation by 2030 will be through renewable energy sources. So right now we are at 23%. So everything else is, with respect to thermal or other ways. So, but from 22 to, we'll have to reach 40% by 2030. So Indian government also has a short-term plan. We say that India is going to target ensuring about 175 gigawatt of renewable energy capacity by 2022. So that could be in the form of solar, which is about 100 gigawatt, wind, which is about 60 gigawatt, biopower, which is about 10, and small hydro, which is about 5. And this particular slide is about integrating your renewable energy system in your building. So again, here the reason that I put this slide is to tell you that if the idea of sustainability is embedded in the heads of the people who are working on the project, then everything becomes simple, because you can optimize your renewable energy system and make it a part of your building itself. So here we have four examples. One, you can install it on the rooftop like a building material. One, you can install it on the wall as a curtain material. One, you can use it as sunshades. One, you can install as your daylight or your skylights in your project. See, this is the beauty of sustainability. Everything is interlinked in one another. Aesthetically as well, it would look beautiful because these are panels which are installed at the same time. That is what I'm trying to get at, the intent. The idea has to be there. The project, the students, the people who are working in this industry should be aware of what they want to achieve, and if they put their heads into it, I'm sure they can achieve it. So some other examples of how PVs have been integrated in the building architecture as well. And so here what GRIHA says is that, with respect to renewable energy, now you've made your building efficient. Now what we need to do is make your building more, cater to that energy requirement of your building by renewable energy generation. So you'll have to, let us say that, as I was giving you an example, 600 units of electricity is what your consumption is. And that is where you will have to cater to that 600 units or a part of 600 units by installing renewable energy systems in your project. So this is about renewable energy. So first thing what I've done is I have reduced my building's energy demand by making my building efficient. The second thing that I've done is I've catered to that requirement through a renewable energy system. The third criteria that we have is about ODP. ODP stands for ozone depleting material or potential. Now the figure that you can see, or the globe that you can see on the right hand side, you see everything green, but there's a blue sortish patch on it. So that unfortunately is the ozone hole that is over the Antarctic, right? So that ozone hole leads to a lot of issues with respect to skin cancer, and because it lets the ultraviolet rays of the sun, the harmful ultraviolet rays rather, to penetrate into the Earth's atmosphere and harm the all creatures. So therefore, we should ensure that this ODP materials are are not used extensively. But where are they used? What are these ODP materials? One is chlorofluorocarbons, hydrochlorofluorocarbons. I'm sure everybody's heard of this, because while growing up, when we were in school, we are taught about what are the refrigerants that are used in our refrigerators: CFCs and HCFCs, halon. There are halones, there are methyl bromide, the carbon tetrachloride. So what is GRIHA trying to do? GRIHA is saying that in your building, you're obviously going to be using your insulation, you're going to be using your HVAC, and you're going to be using your firefighting systems. So GRIHA says in these three aspects: insulation, your refrigerant, and your firefighting system, you should not use ODP material. So you should not use CFCs or HCFCs or halon. Rather, you should use something which is far less harmful. So a fun fact is, back in, I think, 1992, there was something called the Montreal Protocol, which was signed in Canada, where about 192 member countries got together and they said, okay, we are going to stop or reduce the production of these ODP materials. And that has led to a significant sort of change in our environment today. Now, very recently, back in 2015, these 192 member countries got together and they made an amendment to the Montreal Protocol, which is called the Kigali Agreement, or the Kigali Amendment, which was in Rwanda, which was signed in Rwanda, where they said that we are going to be reducing the production of HCFCs by 80%. And sadly, what this reduction is going to do, it is going to reduce or arrest the climate, the temperature rise by 1%, 1 degree Celsius, and that will be by 2100. Meaning, the interventions that we are going to be doing now is something which is going to show positive effects in another 80 years. So imagine the damage that we've already done and the dire situation that we are at this point of time, and the need to go sustainable and the need to construct sustainable buildings, is very, very, very vital and very, very important in today's scenario. So that was about energy. Now we go on to something which you might be interested in, construction management, because this is something which a civil engineer would sort of attribute himself or herself to. So here we have three criteria. One is called air and water pollution control. We have preserve and protect landscape during construction, and then we have construction management practices. Now in air and water pollution control, it is for 1 point. However, it is also a mandatory requirement. So in this particular criteria, we are saying that during construction, you need to ensure that you've taken ample steps in order to mitigate air pollution and water pollution. So some of the strategies that has been mentioned is 3-meter high barricading around the construction area, using of wheel washing facilities, covering of your fine aggregates when not in use, sprinkling of of water over fine aggregates, and if you have a DG set on site, to have the stack height of the DG above average human height and facing away from the site so that it's not polluting the air. So that is what we are talking about with respect to air and water pollution, which is mandatory. Now, in case you have taken care of something called spill preventions, if you have ensured spill prevention, now we all know there are a lot of hazardous materials which would come into your particular site. It could be, in case you're using a DG set, it will be diesel. In case you have if you're going to be laying on roads, you will have bitumen. If you are going to be using admixtures, construction, it will be admixtures which are hazardous. So what GRIHA is saying is, in case you've taken ample steps to ensure that the spillage of these hazardous materials is prevented, then you will be eligible for 1 point. So this is about air and water pollution control. Then we talk about preserve and protect landscape during construction. Now this is for 4 points. However, there is a mandatory requirement. Also, there is something called a non-applicability clause. Please recall, I did say that GRIHA is a common sense oriented rating system. So this is where I'll be able to tell you what we mean by a common sense oriented rating system. So when you get to work on a project, I always say this, it is not just the building that you're going to be constructing. You get to work on the entire site. So there are certain features that would come with the project. There would be certain features that would come with the site. So what are these features? These are trees. These are the existing landscape that comes with your particular site. So what is GRIHA saying is, first, in case you have mature trees on site, do not cut it. It's a mandatory requirement. In case you can, please transplant it. And in case you have to cut it because of site constraints, then you will have to plant trees in a ratio of 1:3 to be eligible for the rating. All right, I will sort of repeat that. If you have mature trees on site, don't cut it. If you have to cut it, plant trees in a ratio of 1:3. And if it's possible, transplant the tree instead of cutting it. So this is a mandatory requirement. You can do either of those three options that you have. Now, again, you might wonder, why are you saying 1:3? I've cut one tree, I'll plant one tree. The reason why we say plant in ratio of 1:3 is because in case, it is about the, chances of that particular sapling growing into a full tree. The chances of one of those saplings going into a full tree is higher than, in case you just plant one tree in place of the one cut. And in case all three trees are up, brilliant, because it's going to make your surrounding much greener. It's going to produce more oxygen. At the same time, it is going to be much more sustainable. So that's the first requirement. The second requirement now I'll talk about non-applicability. You might say, Gagan, what if there are no trees on my site? What do I do then? Because let us say it's a redevelopment project. I am having to redevelop a project. I don't have trees. What do I do? Am I not eligible for the rating? Of course you are. So that is where the non-applicability clause will come into play. So in case your project has no trees, then that requirement of preserving trees and protecting them will not hold good for your particular project. Right? The second thing that this particular criteria talks about is something called topsoil. Everybody, I'm sure, most of you know what a topsoil is, but for those who are not aware, topsoil is that soil on which things grow. It's one of the most fertile resources that is available to us. But what happens in our construction practices, we do not understand the importance of topsoil. We excavate it, we dump, non-fertile soil in it. So during the course of time, the topsoil loses its fertility. But when I have to do landscaping for my particular project, I will procure topsoil from the nursery nearby. So what am I doing? I'm basically destroying my resource. Second thing is I am, spending money and I'm burning more carbon in procuring that particular required topsoil from a nursery. So what GRIHA says is, in case you are able to strip that topsoil, preserve it, protect it for the course of your construction, and reuse it for your landscaping activity, then you will be eligible for points. Here again, there is a non-applicability clause. The non-applicability clause is, in case your soil is infertile or cannot be made fertile, in that particular case, this particular appraisal with respect to topsoil preservation will not be applicable to your particular project. So that is preserve and protect landscape during construction. Moving on to construction management practices. Here, this is for 4 points. There's no mandatory requirements, but here we talk about 4 different things. First is called staging. So how well have you staged your project? Have you provided specific places to store construction materials? Where is your cement being stored? Where are your sand being stored? Where is your building blocks being stored? Have you given designated places on your site to store it? Now, why is that important? Because in case it's done in a very haphazard manner, so you can't call it sustainable, because there's a lot of time that goes into it, a lot of economical losses which can be incurred. The second thing that we talk about under construction management is your providing is conservation of water. Right now, of course, we know that water is something which is used even during construction, post construction. So GRIHA says, if you either use ponding technique or use of SEN cloth for curing, if you use admixtures, if you're using. Am I audible?
Yes, sir, you are audible, sir.
Okay, great. Okay, so yeah, so with respect to preserve, so if the water requirement is, if you are able to take care of or reduce the requirement of construction water, then you will have to, if you are able to do that by adopting 3 strategies. As I said, one strategy could be either using ponding and use of SEN cloth. The second one could be using admixtures. The third one could be using using treated water or preserved rainwater. Then you will be eligible for the points. You'll have to exhibit 3 strategies. One other strategy is you monitoring your water consumption, by either providing metallic pipes, metering it, etc. So then you will be eligible for 1 point. The third thing that this particular criteria talks about is ensuring that there is nothing called soil erosion. Now, when does soil erosion arise? In case there is a if the rainfall, your soil, not the not your topsoil, but everything other than the soil, that would basically flow out of your site. That is not what you want. Therefore, if you have proper measures of ensuring that you have provided strategies to ensure that there is no soil erosion, that will make your project eligible for the point. So that is, you provide rainwater channels, and then you provide something called a sedimentation tank. And the fourth aspect of construction management practices talks about your construction waste management. How are you managing the waste? So there you will have to quantify the amount of waste that is being generated. You will have to have dedicated spaces to store your waste. At the same time, you should also you should also be able to dispose the waste efficiently. You should identify a waste recycler, etc., in order to ensure that it is being done, and that will fetch you points. So this is something which is the last bit of construction management practices. So this basically constitutes your construction management for 9 points. So let's look at some examples. So this is an example of 3-meter high barricading provided around the site. Good practice. Then you see this particular slide is one of my favorites. This is a site which is in Shimla, and if you see, if you can see my cursor, you can see that there are these green barricading that has been provided. And the reason why I have this slide is, normally sometimes the project team says, sir, we are not able to provide the barricading. But in case that a project in Shimla, which is such a contoured site, is able to provide barricading, any project which is on a plain site can definitely provide barricading. Wheel washing facility at a vehicular entry and exit. Of course, the utility of a wheel washing facility is when the wheels get wet, and when it moves into your site, the fine aggregates or the dust would stick to it and it would not rise, hence preventing air pollution. So this is another example of wheel washing facility. Covering of fine aggregates. Why? Because if it's not covered, if there's a gush of wind, then the material can get airborne. Uh, sorry. So this is a bad example. See, the fine aggregates are not covered. Things are spread out. There is no staging which is happening. If you look at the far right corner, there is water stagnation. This is a good example of your DG set having the stack height above average human height. So that is what we want. This is a bad example where the DG with a low stack height. So this basically means that the fumes would directly be going into the particular site, and therefore ensure it gets basically polluted, etc. So that is something that you don't want. All right. So this is a bad example. This is what we meant when we said that you need to do something with respect to with respect to your spill prevention. So here what they have done is the DG that is the diesel that is coming into the DG, that is being stored on an impervious surface. So when you give it on an impervious surface, then what will happen is that it will not seep into the ground, and therefore the soil is not contaminated. And here this is not what we expect, because here you see the DG is the diesel is stored directly on the soil, and because of which there is contamination of the soil that is happening. Now, when I say preserve and protect, I told you that when you get to work on a project, it is not just the project, but it's also the site that not just the building, but it's also the site that you get to work on. Now, this is a brilliant example. This is the IIT Kanpur building. Now, if you look at this particular building, you see these blue marks, or the blue lines. So this is obviously the building footprint, and the green circles are the trees. Now, this is one place where sustainability, is something which is being considered right from the design stage, because they have designed the building in such a way that they avoided cutting down most of the trees. So they've been able to design the building around the trees such that they didn't have to cut down the trees. So building designed to minimize cutting down of mature trees. This again is an example of trees that was transplanted on site. And so it is not just preserving trees, but also protecting them. So we also want you to protect the trees during the construction. And of course, we conduct 3 site visits at different stages of a project, and this is something that we check during our site visits, and this is a mandatory requirement. In case you don't abide by it, then your project will be denied the rating. So this is a good practice of how do you barricade it. This is not a good practice. The one on the left, you have stored sand around the trees. On the right, you have basically stored construction materials around the tree. So what is it going to do? It's going to harm the trunk. And then in case it's too harmful, then it essentially means that the tree might also die. So that is not something that we want. Now, with respect to topsoil preservation, again, so this is a brilliant project. This is a project in Bangalore. If you look into the right-hand side where my cursor is, so this is the topsoil that they stripped off from the site, and they were able to grow something in order to retain its fertility. They have used empty cement bags, which is a construction waste material, in order to ensure that it does not flow out of the thing during the rains. And also they have provided a channel so that even if it runs off, it is going to be stored in that particular area. This is a good example of staging. This is a bad example because here the trees are not protected. The site is poorly managed. If you look at the far side, you can see that the trees, the soil is not protected. The construction materials are being stored abruptly. The waste are being stored abruptly. It's not being managed well. So this is not something that we want. This is with respect to soil erosion channel, sedimentation tank. Now, the one on the right again is one other beautiful example. This is again the IIT project. Now, the brilliance of this thing with respect to sustainability is this. You look at the trees, you look at what is being used in protecting the trees. So this is something where they've used empty cement bags. As I said earlier on, empty cement bag is a construction waste material. So they have actually ensured that the laborers' wives are given employment. They were given a job of, basically stitching it together, and they've used that stitched empty cement bags to protect the tree. So this is a true example of sustainability. So they've been able to save money by not buying more geotextile sheets. Again, if you look at these bricks that have been used at the walls of your sedimentation tank, these were the same bricks that were used to construct the boundary wall as well. So you see, again, they did. And why? Because of course that there is some amount of curing that needs to be done to the red bricks. So they were able to take care of that when the water got saved in the sedimentation tanks itself. So this is again the beauty of sustainability, because if the team has the intent of achieving true sustainability, you can achieve it very easily. These are bad examples because there is water logging, meaning that you're wasting water. And how is it impacting you economically? Now we know in the construction industry, time is money. In case you're not able to deliver a project within a certain amount of time, you're losing crores and crores of money. And why is water stagnation bad? We know water stagnation leads to breeding of mosquitoes. Mosquitoes have are disease carrying insects, so you will probably, in case it bites somebody, they get infected with, say, dengue or malaria or any other mosquito borne disease, then you're going to be using a large amount of your workforce, and lesser workforce will not be able to complete the work on time. So you see, every aspect that you're going to be doing on site is going to affect sustainability. These are good practices with respect to saving water, curing and use of SCN cloths. And then finally, this is a good example of construction waste storage. They have dedicated scrap yards. They've provided bins in order to store plastic waste, food waste, and paper waste as well. Now, another beauty is your construction waste can be employed. I already gave you an example of empty cement bags, but broken cement poles, broken bricks can be utilized in making permanent raised bed for farming as well. So that ends your construction management. Now, moving on to the last section that I want to talk about during this presentation is the sustainable building material. Again, this is something which you people would associate yourselves as civil engineers. So again, this is something which is broken down into three criteria. One is use of BIS recommended waste material in the building structure. So here, when we're talking about BIS recommended waste materials, this could be GGBS, slag, this would be fly ash. Now, fly ash is something which is a waste which comes out of your thermal power plant. Normally, they don't, they end up going to the landfills. So, but then studies have shown that you could use it in your construction as well. Of course, there are certain norms that, you can't replace cement by a certain amount. So, GRIHA says if you are able to replace the cement in your structural concrete and your cement, which is used for your plastering and your masonry mortar, then you will be getting points. Now, if you are also able to show that at least 40% of your building blocks composition is a BIS recommended waste material, again, you'll be eligible for points. So again, here we look at structural concrete. Here we talk about cement that is used for your plastering and masonry mortar, and we are also talking about the building blocks. So this is where we are talking. This is how we are talking about BIS utilization of BIS recommended waste materials. The next criteria talks about reduction in embodied energy of a building structure. So embodied energy is nothing but the energy that is used in order to excavate, produce, process a particular building material, and then transport it and deliver it to your site. So the amount of energy in megajoules is what the unit of this particular embodied energy is. So if your project is able to show us a cumulative reduction in embodied energy, both in structural and non-structural bits, then your project will be eligible for points. Then finally, we talk about use of low environmental impact material in the building's interior. So all these two other criteria spoke about your walls, it spoke about your structure, etc. Now let's talk about the building interior. So GRIHA says if a certain percentage, let's say 25% of your building interior. So what do we mean by building interior? Flooring, false ceiling, paneling, inbuilt furnitures, doors and windows, interior doors and windows, and doors and window frames. If these are low energy materials or green materials, then you will be eligible for points. So this, in simple, is what sustainable building section is trying to capture. So of course, in buildings, we have visible materials and non-visible materials. And in GRIHA, we don't talk about external cladding and finishes, whereas we look at internal cladding and finishes, structural and non-structural. So this is an example of course, there are two types of cements that is used, OPC and PPC. So OPC, in case with OPC, you are adding fly ash or GGBS and replacing it with a certain amount, then you will be eligible for points. And or if you're using a PPC, which has got a certain percentage of fly ash content, you are good to go. Use of fly ash bricks is one other example. So this particular project, I think this is in Naya Raipur. So here they've used AAC blocks for the both load bearing and non-load bearing walls as well. And as I said, embodied energy, if you look at this particular table, the highest embodied energy is with respect to concrete, which is more than 200, I think it's around 210 gigajoules, and followed by steel, which is about 140 gigajoules. If you are able to reduce your embodied energy just in concrete and steel, you will be able to show a drastic reduction in embodied energy, and that is what GRIHA is trying to achieve. So one of the examples how you can do it in your building structure is by using PT slabs. So in PT slabs, what is happening is you are going to be basically using more steel but less concrete, right? So I'm sorry if I'm wrong there, because I'm not a civil engineer, but I understand that is the right concept. You're going to be using a little more steel, but you're going to be using a lot less concrete, and hence you're going to be reducing the embodied energy of the particular project. And some of the examples of interior materials is gypsum false ceiling, engineered wood, and local stones. Local stones in GRIHA's context is any stone in India. So for example, you could be constructing a building in Mysuru, but you have procured the stone from Kota, Rajasthan. It is still going to be considered as a low energy or a low environmental impact flooring. Or for the matter, you could be constructing a project in, say, Himachal Pradesh, but you've got Kadapa stones there. That is also considered a low energy stone. Now, so this basically ends the topic of energy, construction management, and sustainable building materials. And I've also told you the benefits of a green building, but let's look at the benefits of a GRIHA project. So the benefits that I mentioned earlier on, that is more of a generic benefit, but these are benefits which have been quantified from the projects that have been rated by GRIHA Council. So a GRIHA project is able to exhibit about 30 to 50% reduction in energy consumption, which is humongous. So for example, the big IT buildings or the big buildings, they are essentially spending lakhs and crores of rupees every month in energy bills. Now, if you're able to cut that by 30 to 50%, that is a positive, right? So environmentally, you're doing good, and similarly, economically also you're in a good place. Second thing is renewable energy utilization to offset grid demand. So we are endorsing, or we are ensuring that the project is basically going ahead and integrating renewable energy, which is a cleaner source of energy in that particular building. Also, GRIHA projects have been able to exhibit about 40 to 65% reduction in buildings water consumption. Okay, so even so that again, if you look at water as a commodity, it becomes a huge factor with respect to the amount of water that is being consumed, the amount of water that you can save. So about 40 to 65%. Moving on, it ensures in our social section, that is I told about the socio-economical criteria section that we have. So in that section, we are looking at ensuring health and safety of construction workers on site. So that is again something that we are looking into. And then there is a 30 to 40% reduction in operational cost. Of course, if you're able to reduce your energy and water consumption, your operational cost is obviously going to come down. But what is important is with negligible impact on the project cost. So normally, when we try constructing a green building, the first question that comes to anybody's head is, okay, how much is it going to cost? What is my incremental cost going to be? Okay, if I'm going to be constructing a particular conventional building, I'm going to be using, let's say, 1 crore. So if I'm going to be constructing a green building, do I have to spend 1.5 crores? Am I going to be, is my incremental cost going up by 50%? Absolutely not. And that again, my friends, is the beauty of sustainability. It's about, if you have the right team, if you have a motivated team, then you can cut costs drastically, and your incremental cost will hardly be about 2 to 5%. And in case you are very intelligent, you have a very motivated team, then it can probably match what the cost of a conventional building is. Of course, apart from that, 5 to 30% reduction in lighting energy consumption, or its equivalent met through renewable. We're also ensuring waste management during construction, also post-construction, that is during occupancy, and post-occupancy performance audit ensures compliance during operation. Because I'm sure most of you must be wondering, Gagan, you spoke about energy efficiency, but how does GRIHA Council know that my EPI, because you spoke about energy consumption per year, divided by the built-up area, but how do we know that, how is GRIHA giving the rating? Now, when there is something called energy modeling, so when they have to submit documents, they would submit a document called an energy modeling report, from which it is actually a simulation from which we are able to, realize how much energy is being consumed in that particular building. But the beauty of GRIHA is, in the process itself, we have ensured that the final rating is not given to the project when the building becomes operational, meaning that only after the building is constructed, you will not get the final rating. What you will get at that stage is a provisional rating. The final rating is only going to be achieved after the project is completed 1 year since achieving an occupancy of 70%. So meaning that after the building has achieved the occupancy of 70% and has been operational for a year, the project will submit a occupancy audit report from a BE certified energy auditor saying that this is my energy consumption, this is my water consumption, this is my comfort parameters. Only based on that audit report will the project be getting the final rating. So GRIHA Council is ensuring sustainability in design, in construction, and during operation, and also during maintenance as well. So that is what we are looking at in GRIHA Council. Now, another thing to tell you, GRIHA is also, I spoke about NBC, I spoke about ECBC. Now, the thing is, ECBC is a code which is made by the central government, but buildings being a state subject, it has to be adopted by the states. Now, unfortunately, ECBC has only been notified in 11 states or 10 states across the country, which leaves the other states are still yet to adopt. But by mandating the mandatory requirements of ECBC and GRIHA, what GRIHA is also doing is we are ensuring that ECBC is also getting implemented in those states that have not gone ahead and included it in their building bylaws by notifying it. And also by ensuring that renewable energy is being implemented, we are ensuring that we are working on the path of, or the vision that the government has on achieving 40% cumulative power generation through non-fossil based fuels. So the government has realized the importance, and of course, because of that, the government has given certain incentives. So some states such as Himachal Pradesh, Punjab, Delhi, Haryana, Rajasthan, Jharkhand, they give the project something called a free FAR or a floor area ratio, meaning if the project is GRIHA pre-certified, then they get about 5 to 10%. In fact, the highest is in Haryana, where they've given up to 50% additional FAR for a 5-star rated pre-certified. Now, how is that of an economical thing? Consider that you're constructing a commercial building of 1 lakh square meters. So 15,000, so 15% additional FAR for a 5-star rated building means that you get to construct 15% more. So that is 15,000 square meters more. And by constructing 15,000 square meter more of commercial area, you will be making more finances, or you will be making a benefit, in the monetary terms by renting it out. That is one way. Some states or some municipalities like Pune and Pimpri Chinchwad, they have given the discount in premium charges payable to the municipal corporation for both GRIHA and SWAGRIHA projects, and they're also getting about 10 to 15% discount in the property tax for homeowners for the GRIHA and the SWAGRIHA projects. Now, when I was working in the Bureau of Energy Efficiency, we tried to understand why is it that people are not constructing energy efficient buildings. So there we came up with something called the split incentive, meaning that a person is constructing a building, but the same person is not using the building. So you might say that, okay, I can construct a conventional building, but how is that going to affect me? Because I'm not going to be the one who's using it. Therefore, Pune and Chinchwad have identified that giving a benefit to the occupants also will matter a lot, and therefore they've given these discounts as well. And other departments, other ministries rather, like the Ministry of Environment, Forest and Climate Change, it says that if a project is GRIHA pre-certified, then your environmental clearances will be fast-tracked. Also, there is a concession on the rate of interest. Presently, it's about 50 basis points, which is being given by SIDBI, that is Small Industries Development Bank of India. So that comes to the next, it comes to the question, what is the scope of green buildings in India? So it says India will have about 1 lakh green buildings by the year 2025. So in another 5 years, I mean, this is an old report, but that can go up more and more. So the idea is the industry is there. The industry is there to stay. Okay, it's not going anywhere. And considering, I was speaking to Dr. S.K. Prasad the other day and to his colleagues, and saying that probably this pandemic has been a boon in disguise, because during the initial stages of the lockdown, we understood how halting, of course, it's got bad economical impacts on the country, etc. But then look at the environmental benefits that it has led to. The rivers got clean. Why? Because there was no dumping of industrial waste going to the river. People could view a mountain range which is about 235 kilometers away from Jalandhar, which they could not because of the pollution there. The air quality drastically improved in places like Delhi, Bangalore, where it's a constant problem. So in some way, so it makes us think that sustainability is important, and only then will with respect to the jobs. It says that about 1 lakh professionals will be needed by 2025, and of course more people will be required. About 14 lakh people will be required by 2020. Of course, this is an old report. That number would have gone up directly, drastically now. This is our website, www.grihaindia.org. You can go into this particular website, and look. You can download our manuals, etc. We also have something called a GRIHA product catalog, where certain manufacturers such as Parivare, Hindware, or some Asian Paints, they come and register the products so that it becomes easier for the project to document these things. So before I end the presentation, I have one case study that I would like to present to you. I'm sorry, I think I've overshot the time that was given to me, but I want to complete it and give you as much information as I can. So let us go ahead with this case study. This is the ITC Kohinoor. This is a 5-star hotel in Hyderabad. It's got a site area of about 20,000 square meters. It's got a built-up area of close to 50,000 square meters, out of which the air-conditioned area is about 30,500 or 30,600 square meters. Non-air-conditioned area is about 17 or 18,000 square meters. Now, this, considering that it's a hotel, the EPI is very, very less. It's about 79.87, because if you're considering a hotel, it's a 24/7 operational building, and therefore the EPI value has to be more. So they have been able to show an energy reduction of about 82.24%. So like I was saying, the benchmark that GRIHA is set for Hyderabad is about 450 kilowatt hour per square meter per year. Okay, and this particular project is achieved 79 or 80. Apart from that, the water consumption have been, buildings water consumption, they've been able to reduce it by about 54%, which is great. And they have renewable energy installed on site is 5 kilowatt peak. And this project was recently rated, and it's a 5-star rated GRIHA project. Now, what have they done? I told you site planning and your particular, the way that you orient a building is important. So in this particular case, the excavation was done not to coincide with the monsoon season. They adopted spill prevention measures. Construction activities were restricted to pre-designated areas. They planted native trees and they limited turf. Now, another fun fact for those people who are not aware, turf that we get, or the lawn that we get, is not Indian. It is not native, and therefore it requires a lot of water to keep the lush green. It was bought by the British back in when we were a British country before independence, because they wanted to have the lush green feeling that they got back in England or in Britain. And so in order to keep the lush green look, you have to water it more. So this particular project have gone ahead and limited the turf area. They've preserved the topsoil and reused it for landscaping. And please note, the site did not have any existing trees, but they've gone ahead and planted more native trees. Now, only by the passive design architectural features, only by orienting the building, so they've oriented the building at 93 degrees from north, because of which they were able to enable which enables minimum solar gain in summer and maximizes solar gain in winter. What does it do? In summer, the heat gain is less, and in winter the heat gain is more, because when it's cold, you need more heat. So by orienting the building at 93 degrees from the north, they've been able to achieve this. Now, how is that affecting your energy? Again, because it's not heating you much, you don't require the heating system, or your set point that you're going to be setting your AC at will be somewhere between 24 to 26 rather than 16, 17 to 23, which is not efficient. Next, with respect to the fenestration, that is the east and west facade, I gave you an example saying that if your regularly occupied spaces are on the east and west facade, then you will require more heating. But in this case, what they did is they shaded these facades. By shading this facade, obviously shading means there is no sunlight which is entering, and also absence of balcony was compensated by vertical louvers. So in some places they gave balconies, in some places where there were no utility of a balcony, they gave louvers, which again is something like a curtain or say a shading device that is used, so that they can cut the low sun angle. Also, in order to make it more sustainable, they went with green roof, which was able to reduce the temperature in the spaces by 1 degree, and green walls which showed a reduction in the spaces by 3 degrees Celsius. So by that itself, you can see that they've achieved, sustainability with respect to comfort parameters, and also by reducing the demand of that particular building. And also they were able to optimally daylight about 83.42 area of the project, and the WWR, that is the window to wall ratio, was restricted to about 32%. So by giving about 82% of the area with optimal daylight, again, what did they do? They saved energy. How? Because if you have optimal daylight, you will not turn on your artificial lighting. So again, your demand would reduce. With respect to water, they have gone with the 3 R's, that is reduce, recycle, and reuse. So with building, as I said, by using low flow fixtures, they were able to reduce the building's water demand by 53.91%. And by using native species and by using efficient irrigation system, the landscape water demand was again reduced by 63%. Then they installed something called a STP, or sewage treatment plant, of about 140 KLD for grey water treatment and 180 kiloliter per day capacity for black water treatment. For a total of about 320 KLDs of STP was installed. And the water that got treated from these STPs were reused into their flushing, into their landscaping, and their HVAC makeup water. Okay, so basically they've been able to exhibit about 46.57 treated water was reused. With respect to renewable energy, I said 5 kilowatt capacity of solar PV panels was installed on site. However, if you consider, if you are aware of a net zero building, this particular project can achieve net zero because ITC purchased about 46 megawatt of renewable energy from a wind energy, out of which 2.5 megawatt is dedicated to ITC Kohinoor. So if you look at it in one way, 100% of this particular project's energy requirement is being met either by your solar or either by wind. And so, it is basically a building which is running on clean green energy. With respect to comfort parameters as well, the energy efficient artificial lighting was designed as compliance with the ECBC recommendation. Occupancy sensors were introduced into rooms to reduce energy consumption, and external shading and effective glazing was also installed to reduce the heat gain and have glare-free daylight, in the spaces. Thermally also, the envelope was ECBC compliant, which again reduced the cooling load of the AC spaces and met the thermal comfort requirement in non-AC spaces as well. And they went for a very efficient water-cooled centrifugal magnetic chiller of about 400 tonnage and a COP, that is coefficient of performance, of 6.43. And they also installed heat pump of 365 kilowatt of a COP of 3.63. And energy-wise, for the external lighting, they installed automatic timer control, or also known as the astronomical timer control, which basically switches on at 6 p.m. when it gets dark and turns off automatically when the day brightens up. And then they've also used efficient motors, that is IE3 motors. Sorry. With respect to materials, they've gone with gypsum and mineral fiber false ceiling. They've used FSC certified composite wood for the inbuilt furnitures. They've used drywall construction for partition walls, and they provided glass with recycled content and FSC certified wood for partitions as well. And with respect to paneling, they've gone with FSC certified composite wood and stone cladding. However, there is one important factor that they did not attempt, was flooring. The reason is, it being a five-star hotel, they went with Italian marbles. They basically procured imported flooring materials, etc. So which does not fit the requirement of GRIHA, and therefore they did not attempt that particular thing. So finally, GRIHA is, you can follow us on social media as well. On LinkedIn, we have a Twitter page, we have a Facebook page as well, we have a GRIHA YouTube channel. And then we are also there on Instagram. So with that, I basically end my presentation. You have my email address, gagan.kechira@grihaindia.org. So with that, thank you very much. I'm going to stop sharing my screen now.
Thank you, sir. It was a nice presentation. Sir, here we have some few questions. So
Sure,
actually there are more than 10 questions are there, but due to time restrictions, I'm going to ask for 3 to 4. And
So,
for the participants who send the questions,
Ketan,
I will definitely get back to you once we receive the answer from the speaker. So here is the first question to you, sir. That is how to be a member of GRIHA Council.
Okay, very good question. Depends on what kind of membership that you're going to be looking at. Now, in case you are a student and you want to be associated with GRIHA Council, there are two ways in which you can do that. One is called the ACE membership. It is called Agent for Change. You will get more information about it on our website. So there, you become a member and you get a certain benefit. Then also we tend to associate ourselves with the college or the institute itself, and that's where Dr. S.K. Prasad sir, Mr. Abhilash, and myself, and also the faculty of the civil engineering department, we were looking at this being the stepping stone to future sort of engagements. So there are the membership. You can become associated with GRIHA Council as an institute through either the Catalyst membership or an MOU that we signed. Now, there is another way of you associating yourself with GRIHA. So there are two certifications that we offer. One is called the GRIHA Certified Professional, and there's one more called GRIHA Evaluator. So with respect to GRIHA Certified Professional and the Evaluator, you are required to attend a 5-day training. I mean, now it's a 5-day training program because it's an online training program. Otherwise, it used to be a 3-day intensive training program. Once you attend the training program, you become eligible to take up the examination. And on clearing the examination, you become a CP or an evaluator. Now, it is not just a credential that you get. CPs are involved in our training programs because they become the trainers and they are basically given some honorarium for conducting the sessions. Apart from that, we have also basically thought of including these including these CPs or certified professionals as members when we are conducting the site visit. Now, evaluators are again a very important aspect because these evaluators, if you qualify and clear the evaluate examination, you will be evaluating the documents on behalf of GRIHA, for which you will be paid. So these are some ways of associating yourselves with GRIHA. If you go to our website, on the top tab there is something called GRIHA Community. So if you go to the community, there are various ways. All these information will be available to you in a much detailed fashion.
Thank you, sir. It's a great information. And one more thing is to all the information to all the participants is that now there is a link along with the code has been putting on the chat box in a YouTube. Okay, we have received the green signal from the speaker saying that we can share the presentation. So the presentation will be shared to you after 5:30. What you have to do, you have to just click on the particular link after 5:30 and you have to put the particular code that we have given. Once you put the code, you can easily download the resource that you want. Okay. So moving on to the next question to Gagan sir, is that do noise is also considered as parameter in green building rating?
Absolutely, it is. So that is something which is covered under another section which I did not cover today. That is called the comfort section. So in comfort, we look at 3 aspects. So first is comfort parameters with respect to 3 things: visual, thermal, and acoustic. So all these 3 things. So noise is also an aspect with respect to sustainability. Now, how do you do it? That is up to the project, whether you go with walls. If let's say it's a an auditorium where you don't want outside noise, or let's say it's a hospital. So there you can probably go with those noise cancelling sort of facade or the interior materials. Or another simple strategies, again, like I said, planting of trees, or those tall trees itself will ensure that the noise is barricaded. But yes, so noise is something which is also something related, or one of the parameters when you're talking about comfort and sustainability, and that is being addressed by GRIHA Council. Yes.
Yes, one more. Which material to be used for flooring and wall tiling to get GRIHA green building rating?
So, when I speak about the criteria with respect to sustainable building material, I said that we are not going to be individually looking at flooring or cladding. In fact, it's everything. So it is your fall ceiling, it is your cladding, it is your, flooring, it's your internal partitions, it's also your doors and window frames, interior doors and window frames, etc. However, what constitutes itself as a green product in GRIHA for flooring, is ceramic tiles, vitrified tiles. However, these ceramic tiles and vitrified tiles should have at least 5% of recycled content in it. Only and only then will we consider it as a as a low energy material. And as I said, if you want to go for granite, again, it has to be something which is from India, locally made. So that is what your answer is. So any tiles or any material which has a recycled content of 5% and more in it, that can be considered as a material. So, but you like to reiterate, it is not just a flooring. It involves everything. So if you are able to tell me or to tell GRIHA Council that, okay, 25% of my and all these interior things is low energy, then you will be eligible for points. Of course, you do 50%, you'll be eligible for 2 points. If you do 75% of your total thing, you'll be eligible for 4 points.
Yes, thank you, sir. One more is that, is energy consumption depends on material used? If yes, what kind of material you will prefer in general?
Yes, we see it is attributed because there is something called the U value. Now, I'm not going to get into the technicality of it, but it is to do with thermal conductivity of a certain material, which I'm sure all civil engineers are aware of, right? So, normally people go with, AAC blocks and fly ash bricks, etc. Now, by the end of the day, whatever material that you use, in order for you to ensure reduction in energy, and because most of the time, even if you recommend as a project team, it is up to the client whether he wants to accept it or not. So in that case, you can also give insulation. So by providing insulation in your walls, no matter what material, by providing the appropriate kind of insulation, you will still be able to achieve the desired result with respect to your energy efficiency. So, materials normally that I've seen, I cannot say, okay, that this material is the best, but you'll have to analyze which material has the thermal conductivity or, the lowest thermal conductivity, and you can use it. But that again depends on the kind of region that you're in, because if you are going to be using these, materials with low thermal conductivity in, say, the northeast or the northern, in say Jammu and Kashmir, it is not going to work. Why? Because it'll be you'll have to, again, your energy consumption will go high, because you'll have to use energy to heat up the space, right? So using of appropriate materials is up to you. However, in order to ensure that it is meeting the requisite thing, you can do many interventions, such as, let's say, using your insulations and using the appropriate materials. Yes.
Yes, sir. Thank you so much. Still there are questions. As I'm again saying
Chetan,
to the audience.
sorry, just a second. If you want to go over the questions, I'm more than happy to answer them. I don't have a time constraint. If you have it, then then we can. No, I can answer it later on.
Definitely. And then I can go with one more.
Yes, please go on.
Any building using timber doors and windows, will it get green building rating as trees are cut to get these timbers for doors and windows?
So like I said, that comes back to your low impact materials. And again, so not just it is up to a project. Like I said, if you meet a certain percentage, so it is a hit that they take in some place. For example, they go with efficient low energy flooring, but they say, no, I want a timber door. Of course, it's not efficient because you're cutting down trees, but GRIHA is considering FSC certified wood as a low energy engineered wood. So if the project has got an intent of using these, low energy doors and windows, you will be eligible for the points, provided that the other materials are also in place. But just by using a low energy door might not make your building green. Like I said, it's not one aspect, but it is everything that you do with respect to sustainability that would matter.
Yes, thank you, sir. Thank you so much for sharing so much knowledge regarding the green building and rating and everything. So now I request Professor Sharmila ma'am to go for vote of thanks.
Thank you, Chetan sir. Good evening, one and all present. As we have come to the end of today's webinar on energy efficient building, it's my privilege to propose vote of thanks on this occasion. On behalf of our department, I express my heartfelt thanks to today's resource person, Mr. GAGAN KECHIRA, Manager, Southern Zone, GRIHA Council, for enlightening us on energy efficient building. Thank you, sir. It was very informative, sir. I take this opportunity to express my sincere thanks to members of management, VIDYAVARDHAKA Sangha, Mysuru, and to our beloved principal, Dr. B. Sadashivegowda, who were always being the great support for conducting such events. It's pride for me to convey my gratitude to our HOD, Dr. S.K. Prasad, for his continuous support and motivation in conducting this webinar. I extend my heartfelt thanks to Professor Abhilash BL, Professor Chetan L, Avinash, and Bharat Kumar for helping in broadcasting this event. I also take this opportunity to thank coordinators, all my fellow colleagues, technical or non-technical staff who helped in conducting this event. I would also like to thank all the participants for their active participation and also look forward for continued support in future endeavors. Thank you one and all, and stay safe.
Thank you, ma'am. Also, my behalf, as well as from the Department of Civil Engineering, we also like to thank our Gagan sir for taking this time to enlighten us regarding Green Building Council. And also, I'm telling to all the participants that, okay, the material will be uploaded once we receive the material from the resource person. So I think Dr. S.K. Prasad sir is want to speak.
No. I just want to finally thank, that's all. It was a wonderful thing. And Mr. Gagan, very nice of you. Please visit us and we'll keep in touch with you. And we'd like to interact with you more and more. And a good show from all my colleagues. That's all I want to say.
Sure, sir. I mean, thank you very much. On behalf of GRIHA Council and me myself, I think like I said, it's a great opportunity to have presented to institutes such as yours, which is one of the most elite sort of which is rated among one of the elite engineering colleges in the state of Karnataka. And of course, speaking as the manager for the Southern Zone and also as an employee of GRIHA Council, we really look forward for a longer, more meaningful sort of an association with VIDYAVARDHAKA College of Engineering. And let's hope that we are able to finalize something and then associate so that we can make this into a regular thing, so that we can embed the concept of sustainability, in the ethos of all the students and the faculty of VVCE. So thank you very much.
Definitely. I thank you a lot, and we will look forward to that. Okay.
Sure.
And finally, I thank all the audience, that is the participants and everybody who have involved in the particular webinar. And finally, I am signing out as a MC of today's program. And I also wish everybody to be safe and stay home. Thank you. Thank you all.